Now, folks, that's all done there. So you can see there's a very good sort of mesh quality here, and you can measure the face counts as well from that. So just one thing as well, if that doesn't work for you, you need to maybe go back and look at the sort of BOIs we created and kind of use the facets tool to see if there's any protrusions on the mesh on those BOIs, and just to sort of check facets and then auto fix on them and mess around with them, because if there is any errors here, it comes from them and they're not sort of clean enough. And you can always shrink wrap them as well if you're having issues. Okay, Grant, so describe that. So one thing I like to do as well, because I usually have a moving ground, I'll define the ground here as a symmetry plane to not grow a boundary sort of inflation layer on the ground. It saves on the cell counts because you're not going to really have growth of a boundary layer on that, because the relative velocity between the free stream flow and the ground is the same if you're having the moving ground. So you can save a nice bit of cells by not growing that on the ground. You can do it both ways. You can grow it and not grow it and compare your results, and you'll see there shouldn't be any difference. Grand, so mark that as symmetry, and you'll see why here when we're growing. I'll update that region. You'll see here now we grow on only walls, so it won't grow on the ground because it's marked as a symmetry plane. And when we go into Fluent, then we'll change it back to a wall, a moving wall. Okay, so this is sort of a new boundary layer, inflation layer. So it used to do 8 layers. It was kind of nice budget and 0.1 mil cell height. But if you want to go for a faster airflow than say 80 kilometers per hour, say you want to do around 110, 120 kilometers per hour, you'll need a smaller first cell height to keep the Y plus down, and also you want a nice few layers. So this is generally a good sizing for inflation layers. If you're not, and if you're restricted with the budget, go for the old 8 layer one that I showed in previous videos. So update that. And so one thing I didn't mention that's very important, if you do have a bad surface mesh, you can go and improve. You right click on that and click improve surface mesh. Now I'll put it in here just so you can see it. And it's very important to change the number of iterations. Change that to something like 50,000. It doesn't, it takes negligible difference time in doing 5 and 50,000. It's just to make sure that it gives its best go at fixing that. Adjust that, maybe make it like 0.8. And also mess around with these max angle and skewness, change them slightly. So maybe change that to 165, this to 0.9, or adjust them the other ways, make them bigger, smaller, and see if you can fix your surface mesh that way. And if not, just go back to SpaceClaim and fix things up there. Okay, so tidy all this up. So for my volume mesh, polyhex core, and 204.8 is the thing, and then I have an improve afterwards. So I'll just update all that there, and we'll come back to it once the volume mesh is done. Okay. Now we're back. So that's mesh there. So very good mesh quality on it. About 56 odd million cells. So you do want a nice bit of RAM. 128 gigabytes minimum for that. You'd want about 256 though for comfort, but 128 is the minimum. Yeah, so you can sort of use a cut plane to have a look and see what the mesh is like. But I just feel it's a bit clunky sometimes moving around this version of the mesher. So what we'll do is we'll go into Fluent and we'll create a few cut planes and we'll have a look at the mesh then there. Okay, so I'll pause this and open it up in Fluent. So just sort of switch the solution there. Click the button up there. Okay, so we're loaded up into Fluent. So what we'll do is we'll have a look at the mesh. So I'll leave the symmetry plane on there and then display these. So let that load. Okay, and then kind of view it from this angle. So back into display. So we'll go color by type. Let that load, and then we'll turn on the edges here. And then we'll be able to kind of see a little bit of what we've done So you can see there how we have our sort of very fine region near the vehicle, 50 mil very fine cells. Then we have a less finer region outside that, and same again. Then we have a region there on the outskirts there. So you can see the sort of three regions there, and then the kind of coarser one outside of that. And you see how we've captured this as well. What you could also do is you could have that extending down further underneath the vehicle there as well if you want to capture some of that stuff. But yeah, that's just kind of the general bits, and you can also create planes as well here. So if we go create a new plane around cutting maybe through the mirror. So let me fix the display on this so I don't want the edges there. That's enough. I'll turn off the symmetry plane there. Okay. Right, so let's create a new plane, and we'll have the plane going through the mirror. So you want a XZ plane for that. Maybe about 0.9 is where the mirror is. No, a bit higher. It's about 1.2. Maybe 1.3. Okay, 1.35. Do it. Yeah, so that's up through the mirror. So you want to create that plane as such. Then we'll go display mesh again. Best way to do this is come down here into graphics and create a mesh file, or just a mesh of this, and then just highlight your plane there and click display, and good to color it as well too, so it's obvious. So color in red, and we want that to mirror over there. So go to view, views, and mirror it about the symmetry plane. Look down on top now, and then come back into this, and then we'll include the edges. Such. So now you can really see how we've done what we've intended to do. So we have our sort of wake region behind it, and a much finer, you can sort of see the layers. You get the crack. So grand. So nice to see that that can be done in Fluent. So I'll end the video there, guys. Thanks for watching.